All right, today we're opening up a cosmic cold case file. We're going to dive into a pretty radical new theory that claims it can solve some of the deepest, most confusing mysteries in all of physics. And get this, it doesn't do it with new, complicated particles. It does it with a simple, hidden geometry to space itself. Let's get into it.
So our first puzzle starts with a ghost, a particle we call the neutrino. I mean, this thing is so light and it interacts so rarely that literally trillions of them are flying through your body every single second and you don't feel a thing. But here's the real mystery. Why are they just so ridiculously lightweight? An electron, which we already think of as tiny, is over 1,000,000 times heavier. And you know what? Our standard theories in physics, they just don't have a good answer for that.
And oh, it gets so much weirder. Neutrinos are, well, they're cosmic shapeshifters. See, there are 3 different types or flavors of them. As they travel through space, they just spontaneously change from one flavor to another. It's kind of like if you threw a baseball and halfway to the catcher, it turned into a football, and then into a basketball just before it landed. I mean, how is that even possible? But as strange as the neutrino is, it's really just the warm-up act. There is a much, much bigger problem hiding at the very heart of modern cosmology. It's an error so enormous that a lot of physicists call it the single worst prediction in the entire history of physics. No exaggeration. Okay, so here's the deal. Our best theories predict that even totally empty space should be fizzing with a kind of baseline energy. We call it vacuum energy. The problem is, when we do the math to figure out how much energy should be there, the number is astronomical. But the amount we actually observe out there in the universe is 120 orders of magnitude smaller. That is a 1 followed by 120 zeros. This isn't just a little rounding error. It's a catastrophic failure of our deepest understanding of the universe. So we've got 2 major cases on our hands, the bizarre behavior of the neutrino and this impossible energy of the void. So, the new theory we're looking at today, it proposes a single clue that could potentially solve both of these cases at the same time. The core idea is that the fabric of space isn't this smooth, empty thing we imagine. Instead, it has a hidden structure, like a microscopic scaffolding. Imagine for a second that space is actually made of 2 interconnected networks. First, you've got the contact network. Think of this as the universe's superhighway system. It's where all the familiar particles, electrons, protons, all that stuff, live and interact. But then, in between those highways, there's a hidden set of back roads. And this is the void network. And according to this theory, that's where neutrinos travel. They basically live in a different, hidden world, which is why they seem so strange to us.
Okay, so let's see how this new clue helps us crack our first case, the mystery of the shape-shifting neutrino. To do that, this theory completely reimagines what a neutrino actually is.
In this model, a neutrino isn't some tiny abstract point. It's a literal knot. A tiny, incredibly stable figure-8 knot made of pure energy. And it's not moving through open space. It's hopping through the gaps, the voids, in that hidden backroad network. And this is exactly how the theory explains the whole shape-shifting thing. See, the voids in this hidden network, they have different shapes. Some are like 4-sided pyramids, others are more like 8-sided diamonds. As the neutrino knot hops from one shape of void to another, that change in geometry physically forces the knot to wobble, or to tumble. So here's the core idea. What we observe as a mysterious quantum flavor change is actually just the physical tumbling of a knot in space. Simple as that.
Okay, that's a cool story, but a real scientific theory needs more than just a good story, right? It needs to make testable predictions. And this, my friends, is where things get really, really compelling. This model makes predictions about how neutrinos should behave using nothing but the pure geometry of how spheres can pack together.
I mean, just think about that for a second. There's no fudging the numbers, no plugging in unknown parameters. It's just pure, simple geometry. This theory predicts the exact angles that should govern how neutrinos mix and change their identity. So, let's look at the prediction. First up, it predicts what's called the solar angle. This basically governs how neutrinos coming from the sun oscillate. The theory calculates this just from the ratio of the volumes of those 2 different types of voids in the network. The prediction from pure geometry is 35.3 degrees. Second, it predicts the atmospheric angle. Now this one comes from the fact that the neutrino can't take a straight line. It has to take this kind of zigzag path through the network. And the geometry of that winding path, it has a cool name, tortuosity, predicts an angle of exactly 45 degrees. And finally, it predicts the reactor angle.
This one comes about because the packing of this network isn't perfectly crystal ordered. It's a little bit messy, like when you pour oranges into a crate. And that tiny amount of disorder leads to a predicted angle of 8.2 degrees.
And here it is. Here is the payoff. This table puts the theory's predictions right next to the results from decades of real-world particle physics experiments. A prediction of 35.3 degrees, observed at 33.4. A prediction of 45 degrees, observed to be right in that range. A prediction of 8.2 degrees, observed at 8.6. I mean, the agreement is just stunning. All three predictions, which come from one single geometric idea, match reality almost perfectly.
So, it really looks like this geometric model has cracked the neutrino case. But what about that other, much bigger problem? That colossal 10 to the 120 power error in the energy of the universe? The solution here comes from a really profound change in perspective. The old theory, it turns out, made a huge mistake. It assumed vacuum energy fills the entire three-dimensional volume of space. But this new theory says, no, that's wrong. The vacuum energy doesn't scale with volume. It scales with the two-dimensional surface area of the universe, kind of like information stored on a hologram. So, where does this surface energy even come from? Well, the model suggests that for every stable knot, like our figure-8 neutrino, there are also forbidden knots that are just too complex for the lattice of space to handle. The energy that tries to form these knots can't actually become a particle, so it has nowhere to go. It just leaks out and gets spread incredibly thinly across the entire surface of the cosmos. This simple switch from a volume calculation to an area calculation is what resolves that insane 10 to the 20th discrepancy and correctly predicts the tiny amount of dark energy we actually see.
We are so close. We've explained the shape-shifting, we've explained the vacuum energy, but there is one last piece of the puzzle. Why is the neutrino so incredibly light? The answer is this beautifully simple mechanism the theory calls snag and slip. Remember those two networks, the highway and the backroads? Well, the neutrino spends most of its time just slipping effortlessly through that hidden void network, the backroads. And while it's doing that, it's effectively massless. It has no mass at all. But every so often, its path causes it to snag on the contact network, the highway where our particles live, and only for that brief, tiny instant does it actually have mass. So, how often does this snagging happen? Well, the geometry of the network predicts a very specific duty cycle. The neutrino spends about 91% of its time in that massless slip state, and only about 9% of its time in the massive snag state. So that tiny, tiny mass that we measure for the neutrino, it's not its true mass. It's just a time average of this flickering existence. Because it spends over 90% of its life being completely massless, its average mass just appears incredibly small to our experiments. It really is a ghost particle, because it's only truly there in our world for a fraction of a second at a time. So let's just step back for a second and look at the whole picture. One single, elegant idea that space has a hidden geometric structure seems to connect and solve three of the absolute biggest mysteries in physics. It explains why neutrinos are so light, it explains why they shapeshift, and it resolves the vacuum energy crisis. And it does all of this without inventing new forces or extra dimensions, just by looking at the very fabric of reality in a new way. And this brings us to a final, pretty tantalizing thought. If this picture of the universe is right, if fundamental particles are really just knots, and their behavior is just a result of geometry, it suggests that the deepest laws of the universe might not be written in complex mathematics, but in simple shape and structure. Which makes you wonder, if the fabric of reality really is a geometric lattice, what other fundamental truths are still hidden out there, just waiting for us in the gaps?